Hello and welcome to Shudeepa tutorial. This is chapter 1, grade 9 science, matter in our surroundings. This is the module 4 video of this topic in which we are going to discuss in details latent heat of substances, sublimation and evaporation. Before we begin, we have already discussed in our previous module videos about matter and its types, their characteristics, and we have discussed in details density, its units, and examples pertaining to real life. If you have not seen the previous module videos, please do visit Shudeepa tutorial. So let's start. We already know that matter exists in solid, liquid, and gaseous forms. Now the question is, can the solids, liquids and gases convert themselves from one form to the other? And if yes, then what happens inside the matter during this change of state? What causes this change of state? And what happens to the particles, that is molecules, during this change of state? In this topic, we are going to discuss in details about these few questions. Now let's take a real life example. We have studied about glaciers and we know that many of the rivers of our country do originate from these glaciers. Now if you think of these two, that is glaciers and rivers, glaciers are actually the rivers of ice which gradually melts to form the liquid water. And as the river keeps on flowing down and comes to meet the sea, there are cases where we see the river dries down. So in this case, you see the ice getting converted into the liquid water and again the liquid water vanishing and vaporizing. This is a very common example and we see these things happening especially in the lifespan of a river. Now quite connecting to this is an experiment that we are going to do in which we want to observe what happens when a solid is heated and what happens when the liquid is heated. So in the left side, that is figure A, we have taken cubes of ice and we have put them inside a beaker. We are heating the ice, you can see through the burner. We are continuously stirring it with a glass stirrer so that the heat is uniformly distributed throughout the ice. What you observe in the thermometer is that the mercury level goes up. And you all know about this, that the mercury level goes up when there is a rise in temperature. That is happening obviously because of the continuous process of heating. What happens after a certain amount of time is that the ice gets converted into water in the same beaker. And you see that the temperature in the thermometer keeps on rising. So what has happened in this figure A and figure B is the conversion of state, which we were discussing just now. That a solid, that is ice, has got converted to a liquid, that is water, on the application of heat. So now let's discuss what actually happens inside the ice. See what happens here. During the process of boiling, we have taken a liquid. And when we keep on boiling, the temperature of the water increases, which is recorded in the thermometer. You will see a rise in the mercury level with the rise in temperature. What actually happens is the kinetic energy of the molecules of the liquid increases. And when the kinetic energy increases, the molecules, that is the particles, start vibrating with greater energy. They collide with each other. What we see outside is a rise in the level of the thermometer reading. But what happens inside is a completely different story. The molecules are attracted towards one another or are held together very tightly in the solids by chemical bonds. When we keep on heating a substance continuously, the bonds between the molecules break. And the bonds break to such an extent that the substance goes to the next state. That is, the solid gradually gets converted to the liquid state. In this case, the example that we have taken is the water which keeps on boiling. And as you can see here in the figure, when you had started heating the water, The temperature was lower than when it goes to the fourth stage, where the temperature recorded is almost around 100 degrees Celsius. The observation that you make over there is the formation of water vapor, which we generally call as steam. This is the gaseous state of water. What we had started was liquid water. The gradual heating of the water has converted the liquid into a gaseous state. What happens inside the water is the breaking of the bond among the liquid molecules, and the molecules gradually go to the next state of matter, that is the gaseous state. So when you start heating a substance and you observe the thermometer reading, you observe that the mercury level gradually rises up. In this case, you have started heating the liquid water and you keep on heating it. The mercury level keeps on rising and it keeps on rising till it is 100 degrees Celsius. You continue heating the substance, but what you observe in the thermometer reading is that there is no rise in the thermometer reading. The question is, what happens to the heat then? What you actually observe, and I have discussed with you just now, is that the liquid water gets converted to the gaseous form of water, that is water vapor. So the heat that you kept on supplying has been utilized to break the chemical bond between the molecules of liquid water. This heat does not have any external manifestation. That is, you don't get a record of this heat supplied in the thermometer. This heat is hidden. This is called as latent, and therefore this is also known as the latent heat. So remember, whenever there is any change of state, maybe from a solid to a liquid or from a liquid to a gas, there is always a certain amount of time in which the molecules invest this heat or this energy to break the bonds to get converted into the next level. Same is the condition when you gradually cool the substances. This heat will never have any external manifestation in the thermometer and hence is called as the latent heat. This graph will help you understand what I have said just now. You can see on the x-axis heat supplied and on the y-axis there is temperature. You start heating a solid, it gets converted to a liquid after a certain amount of time, and then the liquid gets converted to a gas after a while. As I just now told you, that whenever there is a conversion of a substance from one form to the other, here in this case a solid to a liquid, the latent heat comes into existence. Since the conversion of a solid to a liquid is called as melting or fusion, this latent heat is called as the latent heat of fusion. Now see the next one. When the liquid is converted to a gas, that is called as vaporization. The latent heat in this case is called as the latent heat of vaporization. The temperature in the thermometer readings in both the cases during the latent heat of fusion and the latent heat of vaporization will remain same or constant. Now let's see how we can define latent heat of fusion. It is the amount of heat required to change 1 kg of a solid into its corresponding liquid state at normal pressure at its melting point. Similarly, the latent heat of vaporization is the amount of heat required to change 1 kg of a liquid to its corresponding gaseous state at normal pressure at its boiling point. Why do we mention normal pressure under both the conditions? Remember, pressure has got a lot to do in increasing the boiling point and the melting point of substances. Therefore, it is necessary for you to mention while you are writing the definition of latent heat of fusion or the latent heat of vaporization. So what we infer from this experiment is that the state of matter can be changed from one state to another by changing the temperature. What we also learn is that there will be certain stages where latent heat will come into existence, and at those conditions, there will be no rise in the thermometer reading, though we keep on heating. Now let's come to another phenomena which is called as sublimation. If you see the diagram over here, I'm sure you are aware of the names of the change of the states. For example, when a solid is heated to a liquid, it is called as melting. And the opposite, that is when a liquid is converted or when a liquid changes into a corresponding solid state, it is called as freezing. Similarly, the gas converted to a liquid is called as condensation, while a liquid converted to a gas is called as vaporization. When a gas gets converted to a solid, it is called as deposition. But when a solid gets converted to a gas, it is a direct conversion. The general process, according to the kinetic theory of matter, is a solid should first get converted to a liquid and then liquid to a gas. If there is a direct conversion of a solid to a gas, that process is very special and it is called as sublimation. This phenomena is observed in camphor, iodine, ammonium chloride, the naphthalene balls, and some other substances as well. So if I have to define sublimation, I should define it like a solid getting converted to a gas directly without undergoing a liquid state is called as sublimation. In this case, what you have to remember is it is not true that a solid gets converted to a gaseous state directly. There is definitely a liquid state, but the liquid state is very short lived. It happens for a very short while, therefore, it is not easily observed. What is observed is the original solid state and the final gaseous state. Therefore, we say that a solid is getting converted to a gas directly, which we call as sublimation. Now let's see an interesting experiment. Just now I have discussed that ammonium chloride is such a substance which undergoes sublimation. This experiment can be very well performed in the laboratory. Take a china dish in which you take a mixture of ammonium chloride and salt. You cover it with a funnel, which should be a glass funnel, so that whatever conversion of state is happening inside is easily visible. You heat the ammonium chloride. After a while, you will see the vapors of ammonium chloride. If you wait a little longer, you will see solid ammonium chloride stuck to the walls of the funnel. In this case, remember, we have to use a cotton plug to block the outer exit of the funnel. Otherwise, the vapors of ammonium chloride will disappear and we will not be able to observe the conversion of solid ammonium chloride into the gaseous ammonium chloride and directly to the solid ammonium chloride again. So this experiment shows clearly that ammonium chloride gets converted to the vapors, that is the gaseous state of ammonium chloride, and then the gases directly condense to form the solid ammonium chloride. What is missing here is the existence of the liquid state. Therefore, it is a very suitable example of sublimation. Now the next part is, has pressure got to do anything with change of state? Now let's see another experiment. The effect of the change of pressure. As you can see here, the three cylinders in which the pistons are present, and you can see matter, that is the molecules present inside cylinder. What we are trying to show by the three cylinders is the quantity of pressure that is applied. In the first one, the application of pressure is less. In the second one, it is gradually increased to the third one, where there is a maximum increase in the pressure. This experiment clearly proves that there is definitely an impact of the application of pressure on substances. Applying pressure and reducing temperature can definitely bring a change in the state of matter. It can liquefy gases very easily. In this case, a very suitable example is the formation of solid carbon dioxide, which is stored under very high pressure. Solid carbon dioxide gets converted directly into the gaseous state on decreasing the pressure to 1 atmosphere without coming to the liquid state. This is the reason why solid carbon dioxide is also known as dry ice. Therefore, we can also say that pressure and temperature do determine the change of state of substances. Now let's come to another very important phenomena, that is evaporation. We all have heard about this term evaporation, which actually means when you are applying heat to a substance, specifically the liquid, it gets converted to the corresponding gaseous state. And definitely it happens through the process of boiling in most of the cases. But there can be some real life connections which we are going to discuss in a short while, in which heat is enough but you may not observe the process of boiling, still evaporation might happen. So the question is, what actually happens in the process of evaporation? If you think very critically, we have discussed that when a substance, for example a liquid, has to go to its next state of matter, that is the gas, there has to be a supply of energy. Suppose in this case, as the figure says, you are heating the liquid. What happens here is that the kinetic energy of the molecules increase, molecules start vibrating faster, the bonds between the molecules, that is the liquid molecules, break and they overcome the force of attraction between the molecules and get converted to the corresponding state of matter, that is the gas. This is what happens at the molecular level during evaporation. Now let's discuss the factors that affect evaporation. If you want to evaporate a liquid faster, and I give you two examples, A and B. A is a flat vessel, B is a vessel which has edges. Which one do you think will be better suitable to evaporate a liquid faster? If your answer is A, then you're exactly correct. Evaporation happens faster when there is larger surface area. Now let's take the second set of examples. Observe the condition of nature. On the left hand side, that is figure C, you see a bright sunny day, and D, you see a cloudy day. Under which of these two conditions will evaporation take place faster? If your answer is C, then you are correct. On a sunny day, heat will definitely have an impact on the process of evaporation. Also, if it is windy, then it will be better. So you may think that in the figure D, there is a lot of wind blowing. Then why is it that I am saying that in case of figure C, the evaporation will take place faster? So the reason is, under a cloudy condition, there is a lot of humidity, that is the moisture or water vapor content in the atmosphere is higher. Therefore, it will not allow evaporation to take place faster. So the condition C, that is the impact of the heat of the sun, the blowing of the wind, and less of water vapor in the atmosphere will support evaporation to happen faster than condition D. So what we learn from these two sets of example is increase in temperature allows evaporation, rate of humidity decreases evaporation, and more the surface area, the evaporation will happen faster. We have always heard that evaporation has a cooling effect. And we have often done this as kids, that after bathing, we directly come and stand under the fan and we feel very comfortable. Why does this happen? It happens because the blowing of the wind promotes evaporation of the water droplets present on the wet skin from our body. And when the water droplets evaporate, it takes away the latent heat from our body and gives us a cooling sensation. Similar is the case when we use eau during bathing or even if we touch nail polish remover on our skin. The chemicals present in these two substances allow the loss of heat from our body by the process of evaporation. Now let's discuss some examples of evaporation which has real life connections. We always prefer to wear cotton clothes and especially light colored cotton clothes in summer. That's because during summer, as a normal tendency, we have a lot of perspiration, that is sweat coming out of our body. Cotton is a very good absorber of water and naturally it absorbs the sweat from our body. Hence, the cotton dresses allow a lot of loss of water and the latent heat of our body to get vaporized. So, we prefer wearing cotton clothes in summer. And why do we wear light colored clothes? That's just because light color do not absorb heat in the same quantity as a dark colored cloth does. We have often used earthen pitchers, which we call as matka, in our houses during summer. We store water and the water is equally cold as a refrigerator water. Earthen pitchers have pores on the outer surface which allows evaporation. Generally, the heat during the summer is so high that water gets evaporated even when it is kept inside vessels like the earthen pitcher. So while this process of evaporation takes place through the pores of the pitcher, the latent heat of vaporization is also lost. Hence, there is a reduction in the temperature of the stored water. You must have observed water droplets around the body of a bottle or a glass when you take it out of the refrigerator and keep it undisturbed for a while. That's just because the warm air present around the bottle or the glass comes in contact with the cold surface and condenses to form water droplets. And that is the reason why you see these water droplets around these vessels. That's all for this module. This is the summary of the topic which is there in your textbook. You can go through it. Like, share and subscribe to Shudeepa tutorial. There is an assessment link in the description box below. Kindly solve it to improve your performance in the exam. Thanks for watching.